In a small bowl, combine 1 cup of warm water, around 100 degrees Fahrenheit to 110 degrees Fahrenheit, and 1 packet or 2 1/4 teaspoons of active dry yeast. Stir gently to dissolve the yeast, then let it sit for 10 minutes or until it becomes frothy and bubbly. In a large mixing bowl, whisk together 3 cups of all-purpose flour, 1 teaspoon of salt, 1 teaspoon of sugar, and any other dry ingredients you're using, such as herbs or spices. Make sure to get rid of any lumps in the flour. Add 1 tablespoon of olive oil, the yeast mixture, and water to the dry ingredients. Mix everything together until a shaggy dough forms. Turn the dough out onto a clean work surface or a lightly floured countertop. Use your hands to knead the dough, pushing down and folding it back up towards you repeatedly. Continue kneading for about 10 minutes until the dough becomes smooth and elastic. Place the dough in a lightly oiled bowl, turning it to coat evenly. Cover the bowl with plastic wrap or a damp towel. Let the dough rise in a warm, draft-free place until it has doubled in size. It should take about 1 to 2 hours. Punch down the dough to release any air bubbles. Shape the dough into a loaf shape, either by hand or using a bench scraper. Place the shaped loaf onto a baking sheet lined with parchment paper. Cover the loaf with plastic wrap or a clean towel and let it proof for another 30-45 minutes. Preheat your oven to 375 degrees Fahrenheit, 190 degrees Celsius. Place the loaf pan in the oven and bake for 25 to 40 minutes, or until the bread is golden brown and sounds hollow when tapped on the bottom. Rotate the loaf halfway through baking to ensure even browning. Remove the bread from the oven and let it cool on a wire rack for at least 10 to 15 minutes before slicing. Store any leftover bread in an airtight container or wrap it tightly in plastic wrap.
Plastic injection molding involves melting plastic pellets and injecting them into a metal mold cavity using an injection machine. The molten plastic fills the mold, cools, and solidifies, taking on the shape of the mold cavity. Once hardened, the part is ejected from the mold and undergoes various processes to achieve its final form. Key components: injection machine. This is the core component of the molding process. The machine consists of a hopper or tank to store plastic pellets, an extruder or screw that melts the pellets, a hydraulic system or electric motor that drives the injection process, a control system that monitors and regulates temperature, pressure, and flow rate. Mold. This is a metal tooling made from materials like aluminum, steel, or copper. The mold has 2 halves, the upper A and lower B halves. The upper half contains the ejector pins, which push the part out of the mold after it's cooled. The lower half contains the runner system, which allows molten plastic to flow into the mold cavity. Material handling. Plastic pellets are fed from a storage bin or hopper into the injection machine. Manufacturing process. Here's a step-by-step explanation of how plastic injection molding works. Preparation: clean and prepare the mold for use. Load the required amount of plastic pellets into the machine's hopper. Heating and melting. The plastic pellets are fed into the extruder, where they're melted to a temperature between 180 degrees Celsius, 356 degrees Fahrenheit, and 250 degrees Celsius, 482 degrees Fahrenheit. The molten plastic is then forced through a nozzle, creating high pressure up to 10,000 psi. Injection. The molten plastic is injected into the mold cavity through the runner system. The injection machine controls the pressure and flow rate of the plastic to ensure it fills the mold evenly. Cooling and solidification. The plastic cools and solidifies in the mold, taking on its final shape. This process typically takes a few seconds to several minutes, depending on the material, thickness, and complexity of the part. Ejection. Once the part is hardened, the ejector pins push it out of the mold. Post-molding processing. The ejected parts are collected and undergo various processes such as ejection, removing excess material, degating, removing the runner system, surface finishing, sanding, polishing, or applying coatings. Key benefits. High volume production. Plastic injection molding allows for high volume production of complex parts with precise dimensions. Cost effective. This process is more cost effective than other manufacturing methods, especially for small to medium-sized production runs. Material variety. A wide range of plastics can be used in injection molding, offering flexibility and customization options. Common applications. Electronics. Plastic components for electronic devices, such as phone casings, computer parts, or consumer electronics. Automotive. Interior and exterior trim parts, dashboard components, or under-the-hood components. Medical devices. Sterilizable parts, surgical instruments, or medical equipment components.